Notice, and this is the typical copyright, we continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos, sections 1, 2, and 3. All 51 of those videos have been published on YouTube in their entirety. Section 4, measurement. All 17 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 5, statistics. All 18 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 6, algebra. This is the 20th of 22 videos. Section 7, relations, functions, and graphs. Hopefully that will be finished by next month, October 2025. Section 8, geometry and trigonometry, by November 2025. And finally, Section 9, vectors and matrices, by December 2025. That's the end of this year. Please note this disclaimer down here. This schedule is just a projection and it is not to be interpreted as a contract with, as I said, Section 1, number theory and computation. It's made up of 33 videos and they are all published in their entirety on YouTube. Specifically because this section forms the foundation on which the rest of the syllabus is based. So make sure you look at these 33 videos and know them very well in order to be successful for the rest of the syllabus. Reminder here that you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Section 2, consumer arithmetic. All 12 of these videos have been published on YouTube in their entirety. Section 3, sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, measurement, with 17 videos. These indicated in yellow here have been published on YouTube in their entirety. The others are only partially published. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 5, statistics, 18 videos. These 5 out of those 18 have been published in their entirety on YouTube as indicated, and the others are only partially published. Again, please see directions in the description below for full access to these videos that are only partially published on YouTube. We are now at section 6, almost to the end, algebra. This is made up of 22 videos from 21 objectives. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get more practice questions, especially. CSEC recommends the following, shown at right. From those, please pay close attention to these last 2 here, especially since they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. This is a picture of volume 1, mathematics, a complete course with CXC questions by Raymond Tulsi. And this is a picture of volume 2. Disclaimer down here. Please note, I get no financial or other benefits from the sale of these books. Also, very recently, late last year, I think, 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely that will be explained for you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page looks like. And this may be slightly different from the one in previous videos. So this is what it looks like. Again, this is the URL. This URL will be in the description below so that you can easily click on it and be redirected to this website. You would have to register first and then sign in. I show you what an example looks like right now. We are looking at objective 19. Prove two algebraic expressions to be identical. I typed that in at that website. So this is what I typed in. How to prove two algebraic expressions to be identical. And then I searched and I got this. To prove two algebraic expressions to be identical, you generally have a few common strategies. Actually, there are three. It goes on to explain the first one and the second one and so on. Let's see that a little clearer on the next slide. To prove two algebraic expressions are identical, you generally have a few strategies. As I said, two, and it goes on to give you the first one, simplify both expressions. We will come to that later on in this video. And two, transform one expression into another. That is all this window could show. There is a third one if you scroll down. That's just to introduce you to that website. A reminder that this formula sheet is provided for CSEC math examination papers that you see here on the left. There will be a link in the description below from where this formula sheet can be downloaded. Of course, if you have the full syllabus, it is in the syllabus. This is the top part of that formula sheet, so you could see it a little closer. Please note that you do not need to learn these formulae on this formula sheet, as this sheet will be provided during the math examination, as I previously said. And this is the below part of that same formula sheet. And while you do not need to memorize these formulae, you do need to know when and how to use them. So section 6 algebra overview, we have completed objectives 1 to 4 from that page. And more overview, we have completed objectives 5 to 7 from this page. That's all on this page. And then on this page, objectives 8 to 11, they have all been completed. On this page, objectives 12 to 16, that's all of them, have been completed. We are now here on the last page. These two, 17 and 18, have been completed. And now we are at objective 19, which will be done in video 20 here. As I said, we got up to video 19. These 6 have been published in their entirety on YouTube, as indicated in yellow here. The others are only partially published on YouTube. We are now here, video 20, objective 19. When this is finished, this will only be partially published on YouTube. So objective 19, which says, prove two algebraic expressions to be identical. And we have some explanation here. Equations versus identities. What is the difference? So what is an equation? It is a statement that says that two mathematical expressions have the same value. Now, that's not quite clear. Of course, that's taken from page 61 of the syllabus. And then page 62, defines an identity, which says that it is an equation that is true for every possible value of the variables. For example, x squared minus 1 will always be x minus 1 times x plus 1. It is an identity. While x squared minus 1 is equal to 3 is not. This is an equation. This one below here is an equation. And it is only true for values of plus and minus 2. So identities are really subsets of equations. They are type of equations. Now, firstly, how are algebraic equations different from algebraic identities? As we just found out, we may not understand that quite clearly. So let's consider here. If you consider this expression here, 3y plus 5 is equal to 35, solve for y, and so on. For each of these, you are required to solve the equation. So at the end, you should say something like x is equal to something or y is equal to something else. That's an equation. Now, if you consider these here, prove that x squared is equal to x plus 4 times x minus 4 plus 16. You don't have to end up with solve. You have to prove that the left-hand side is equal to the right-hand side. Now, these down here are not equations, or well, they are a special kind of equation, but you don't have to solve them. You have to show that what is on the left-hand side is the same or equivalent to what is on the right-hand side, is identical to what is on the right-hand side. Right now, they don't look identical. And to help do that, there are some shortcuts called algebraic identities that can help us with these proofs, but we really don't need them. But if we have them, we can use them. Now, the four most common algebraic identities are these, and we have seen these already when we were doing factorization. First one, a plus b squared will always be a squared plus 2ab plus b squared, always. For example, if we expand that, we will end up with this. So we can see the left-hand side is the same as the right-hand side. That's one. Another one is a minus b squared will always be a squared minus 2ab plus b squared. If we expand that, we can see that that on the left-hand side is actually the same as this on the right-hand side. The second one. The third one is a minus b times a plus b. That will always be equal to a squared minus b squared. If we expand that, this is what we get. So this is the left-hand side is equal to the right-hand side. And finally, the fourth one, x plus a times x plus b will always be equal to x squared plus a plus b x plus a b. Now, this one is a little harder to understand than the other three. So let's expand it. And we can see that this here on the left-hand side, if we expand it, is equal to that there on the right-hand side. So, how to apply? For example, 2x plus 4 times 3x plus 5. If you expand that, what do you get? You get this. So hold a moment. Hold on. I thought we said a plus b x. Now, if you add a and b, we will get 9. Why is there a 22 here? Well, that works only if the x's in the binomial have 1 as their coefficient. In other words, if this was 1x plus 4 and that was 1x plus 5, then this middle coefficient here will be a plus b, which will be 4 plus 5, which will be 9. But because of this 2 here and that 3 there, this is now 22x. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. So as I said, the 4 most common algebraic identities, and remember these are special types of equations, are these that you see here on the left hand. If you can memorize these algebraic identities, that will help you save a little time in examinations. However, you can easily derive them using 3 simple principles. If we are going to expand that, here are the 3 simple principles. Multiply the first 2 terms of the binomials and write that down. So you multiply 2x by 3x and you get 6x squared. That's the first term in the expansion. Secondly, multiply the last 2 terms of the binomials and write that down on the far right. So now we multiply 5 by negative 6 and we get negative 30. So we have the 2 extremes. We need to know what to put in here. How do we get that? Thirdly, multiply the 2 inside terms and then the 2 outside terms and add them for the middle term of the trinomial. So you multiply 2x by negative 6 and then you multiply 5 by 3x. You add those and you will get positive 3x. Another way to look at this, we set it down like that. We multiply these two and we get this. Then we multiply those two and we get that. And finally, you multiply this one by that, you get this, and multiply this one by that over there, you get that. Those two will give us positive 3x with the rest of the stuff following. So 6x squared plus 3x minus 30. Okay, now that we have that out of the way, let's actually do a few of these examples to prove that 2 algebraic expressions are identical.